Welcome to the Applied Biosystems Taq Talk video series, where we break down real-time PCR to make it easier for you. PCR can be broken down into three distinct phases: geometric, linear, and plateau. Understanding the phases is particularly important for real-time PCR because only one phase yields high-quality quantitative data, and that's the geometric phase. Let me explain why. When we first start our qPCR reactions, there's a molar excess of all the reagents needed for amplification. As a result, we typically get a nice doubling of product with each cycle. In an amplification plot set to log scale, we see that exponential increase as a straight line. This phase is known variously as the geometric, log, or exponential phase. Unfortunately, this doubling doesn't go on forever. At some point, the reagents in the tube, primers, DNTPs, and so on start to run low. As a result, the reaction slows down. We call this the linear phase. Finally, after some point, assuming the plate is run for enough cycles, the reactions run out of some critical ingredient. As a result, they come to a halt. We call this the plateau phase. As I already mentioned, we really only care about the high-quality quantitative data generated during the geometric phase of the reaction. Now, to see why, let's take a look at an example file. In this run, we took a highly concentrated sample and serially diluted it in 10-fold increments over 7 logs. We also ran 8 technical replicates for each dilution point. What I want you to notice is this. In the geometric phase, which is approximately the area inside this box, all the dilutions are very evenly spaced, exactly as we would expect. Also, the pipetting replicates are very tight, meaning we have excellent precision. But as the reactions move into the later cycles, the so-called linear phase, that predictability starts to go away. Our nice straight lines begin to curve, totally messing up the even spacing, and the precision drops off considerably. Finally, in the latest cycles, also known as the plateau, the data all merge. That's not very useful if you ask me. The point is, we always want to look at our data in the geometric phase, since this is where we'll get the best results, especially for a quantitative reaction. Now, how do you know you're analyzing data in the geometric phase? Well, by making sure that that's where the threshold is set. Luckily for you, we have a Taq Talk all about setting the threshold. Thanks for watching.